We're going to go back and pick up extra practice problems from section 1.5 of college algebra. So we had already solved an open top box, but now we're going to repeat the problem with the length being twice the width, and then the squares are 10 centimeters and the volume is different. So we've still got this rectangular piece of sheet metal. This time the length is going to be twice the width. So here's our width. And then the squares we're cutting out are 10 centimeters. And then the volume when we're finished is supposed to be 7,500. So our finished box is going to have a smaller length and width than the original sheet metal. For the length and width of the finished box, I have to take 10 centimeters off both ends. So the width of the finished box is going to be not W, it's going to be W minus 10. And the length of the box is not going to be 2W, it's going to be, it's not minus 10, it's minus 20, there's two of those squares. The length is going to be 2W minus 20, because there's two squares that get cut out. And then the height of the finished box is going to be the length of that cutout, so the height will be 10. So our 7,500 volume is going to be the 2W minus 20 times the W minus 20 times the 10 from the height. So when we FOIL that out, or box multiply it, 2W minus 20, W minus 20. We got 2W squared minus 60W plus 400, and then times 10. So kind of what I was thinking about doing on the problem earlier is just dividing both sides by that number there so that I could avoid taking out as a GCF. So you could do that if you feel confident doing that. I'll go ahead and multiply it in just to keep things simple. Then to solve this quadratic equation, I need to get it equal to 0, so I will subtract that 7,500 over. So now I have 0 equals 20W squared minus 600W minus 3,500. Let's see if we have a GCF. I think we can take 20 out. 3,500 divided by 20. Yes. 600 divided by 20. Yes. So I can take out a GCF of 20, and I get W squared minus 30W minus 175. And that's way nicer to factor than our original problem was. 175 is 7 times 25 for 35 times 5, and that's going to be the combination that works. So we got W squared negative 175, negative 35W and 5W. So there's a W, 5, negative 35. So once we have it factored, it's 20, and then W plus 5, and then W minus 35. That GCF that's 20, we ignore because there's no variable. W plus 5, when we set that equal to 0, we get W equals negative 5, which we're going to ignore because we can't have a negative width for that sheet of metal. When we set W minus 35 equals 0, we get W equals 35. So our original sheet metal would have been a width of 35 centimeters. And then remember that the length was 2 times the width, so it would be 70 centimeters. Okay, let's look at our next one. Our next one is going to be the Pythagorean theorem triangle problem. This time we have the same problem. We've got our field. They're telling us that the longer leg is 10 meters shorter than twice the shorter leg. Hypotenuse is 20 meters longer than the longer leg. So again, I'm going to have x be the length of the shorter leg. And then the longer leg is 10 meters shorter than, which means subtract 10 from twice the shorter leg. So subtract 10 from 2x. So this guy will be 2x subtract 10. And then the hypotenuse is 20 meters longer than the longer leg. So the longer leg was 2x minus 10. 20 meters longer than means add 22. So if I take 2x minus 10 and add 20 to that, I get 2x plus 10. Now to find the dimensions of this triangle, the field, I'm going to use Pythagorean theorem. So I will take a squared, which is x, plus b squared, which is 2x minus 10 squared, equals c squared, which is 2x plus 10 squared. Remember, to solve this, we need to go ahead and expand these parentheses. So the x squared one is easy. 2x plus 10 times 2x plus 10 is going to be 4x squared plus 40x plus 100. Oops, that's on this side. 4x squared plus 40x plus 100. But when I do 2x minus 10 times 2x minus 10, all that's going to change is this sign will be negative, which makes these signs negative. So all I really have to change on this side is to make my 40x negative 40x. Then we're going to go ahead and solve this. It's quadratic equations, so I'm going to move all my terms to one side so that I get equals 0. That is going to give me x squared minus 80x equals 0. Hey, this looks a lot easier to solve. I see a GCF here of x. When I factor that out, I get x minus 80 equals 0. And there's nothing left to factor, so I set each of these equal to 0. And I get either x is 80 or x is 0. Since x is the length of the short side of the field, it doesn't make sense for it to be 0, so I'm going to ignore that. And I'm going to say that the short side is 80 meters. Then the long side was 10 meters shorter than twice that. So if I do 2 times 80 subtract 10, I get 160 minus 10, or 150 meters. And then the hypotenuse was 20 meters longer than the longer leg, so I just could take the longer leg of 150 and add 20 to get 170 meters, or I could use the formula 2 times x plus 10 to get 160 plus 10, which is 170. The next extra practice problem had to do with the projectile height. So remember that made an upside down parabola. And then we were basically given some scenarios that we had to solve. I'm sorry, there's probably a squirrel on the porch. Okay, so we have a projectile launched upward from the ground with an initial velocity of 73.5. Now we're in meters per second. Then its height is given by s equals negative 4.9 t squared plus 73.5. So when you're measuring in meters per second, your force due to gravity is, acceleration due to gravity is negative 4.9. After how many seconds to the nearest hundredth will the projectile be 100 meters above the ground? So this 100 meters above the ground is s. So they're asking us to figure out what is t when s is 100. So I put 100 in for s and try to solve for, oops, this is supposed to have a t on it, you guys. There was a typing error in the notes here. That should have a t. 73.5 t. Okay, this is a quadratic equation again. So I'm going to get this to equal 0, but I want my leading term to be positive. So I will go this direction. I would pause this, but I can't. There's not a pause function on this. I apologize. So now I have 4.9 t squared minus 73.5 t plus 100 equals 0. So to solve for t, I either need to factor or use a quadratic formula. It doesn't look like it'll factor well, so we're going to do quadratic formula here in a second. So in the quadratic formula, we have a is 4.9, b is negative 73.5, and c is 100. So we'll say t is equal to opposite of b, 73.5, plus or minus square root of 73.5 squared, which is 5,402.25 minus 4 times a times c, and then all divided by 2 times a. Again, we're going to put that into our calculator. So I'll take 73.5 plus the square root of 5,402.25 minus 4 times 4.9 times 100. I'm going to get that answer. Then I'm going to divide it by 2 times 4.9 is 9.8. So I'm just going to divide it by 9.8. And that is going to give me an answer of 13.4868. And since I'm going to the nearest hundredth, that will be about 13.49 seconds for one of my answers. And then I have to do the subtracted one. So I'll just snag what I just typed, change the addition to subtraction, and divide by 9.8. So we get 1.51 seconds. In B, it says, how long will it take for the projectile to return to the ground? Returning to the ground, that's the height, which is s. So s equals 0. So I go 0 equals negative 4.9 t squared plus 73.5 t. That is a quadratic equation. I'm going to go ahead and factor it by taking out a GCF. They have t in common, but I'm going to factor out negative t. So that'll leave me with 4.9t minus 73.5. Setting each of those equal to 0 gives me t equals 0, which is where it started. So that's not returning to ground, that's starting on the ground, so I'll ignore that one. Or 4.9t equals 73.5, so t would be 73.5 divided by 4.9. So let's see, 73.5 divided by 4.9 is 15. So it takes 15 seconds for that to return to the ground. Can you please not bark? Okay, extra practice on modeling. So remember on these ones, they just give you an equation and then they start asking you questions. In this problem, iPod sales from 2006 to 2014 follow this equation. X equals 0 represents 2006, X equals 1 represents 2007. So they're telling you S is sales in millions of units, so that's here. And then X is how many years after 2006. So using the model to estimate sales in 2012 to the nearest tenth of a million units. So 2012, X would be 2012 minus 2006, which is 6 years. Because 2006 is 1, 2007, 2008, 2009, 10, 11, 12. Oh, 2006 is 0. So 2007 is 1, 2008, 2009, 2010, 2011, 2012 is 6. Okay, we got it. So X is 6. We're just going to sub 6 into this equation. So we would have S equals negative 1.43 times 6 squared plus 7.64 times 6 plus 42.8. Literally just typing that into the calculator. Negative 1.43 times 6 squared plus 7.64 times 6 plus 42.8 is 37.16, and we're supposed to go to tenth of a million, so that is going to be 37.2 million. Compared to 35.2 million, I would say that the model is 2 million higher than the data. For 2012. Okay. Next question, last question. According to the model, in what year beyond 2006 did sales reach 40 million units? Round down to the nearest year. Molly, stop. So this is where S is 40 million. So we're going to set 40 million equal on this side equal to negative 1.43x squared plus 7.64x plus 42.8. And then to solve this quadratic equation, it looks like I will need quadratic formula. So I'm going to move everything over to the left side because you know I like that leading coefficient to be positive. So I will end up with 1.43x squared minus 7.64x minus 2.8 equals 0. And then for quadratic formula, A is 1.43, B is negative 7.64, and C is negative 2.8. So we'll go X equals the opposite of B, 7.64, plus or minus the square root of B squared, 64 squared, 58.3 0.3696 minus 4 times A, 1.43 times C, negative 2.8, and then divided by 2 times A, which was 1.43. That makes that 2.86. So that'll save us a minute when we're doing our calculator stuff. So we'll do the calculator again, 7.64 plus the square root of 58.3696 minus 4 times 1.43 times negative 2.8. Enter. Divide that by 2.86 and we get 5.68696. They said round down to the nearest year, so I'm going to round that to 5 for X, which is going to make it in the year 2006, because year 0 is 2006. So 5 plus 2006 would be the year 2011. I was thinking of the other problem where it was the year 2000 was year 0, but this one is 2006. So add 5 years, that's the year 2011. Let's see what we get from the subtraction one. So go up and grab that computation, change the addition to subtraction, and then divide by 2.86. Oh, and that's a negative. So negative 0.344. So if I round that to the, that doesn't even make sense. We have to ignore the negative because it's time. It's in the past. So we're just going to stick with this year 2011.